Hi, my name is Dee Shore. I am the Standards and Open Source Advocate within OASIS. And welcome to the Simplifying Your Cloud Deployment with MQTT 5. This webinar will be recorded and available after the session. We will follow up with an email. Questions will be addressed at the end of the webinar, but feel free to type in your questions at any point in the question box. You can see it along the bottom ribbon during the session, and we hopefully will get to all of them. If we do not, please feel free to follow up afterwards and we'll try and get those answers for you. Just one quick minute, tell you a little bit about OASIS. Many of you are familiar with OASIS, and but some aren't. So just briefly, just a couple sort of seeds to plant about OASIS. We are the home of a lot of standards that you probably use every day. When you open many Office applications, you're using open document format. When you sign on to a website, you're probably using SAML. If you unlock your car using your phone, you're using MQTT. For those of us in the United States, when you get an Amber Alert message, that's the OASIS Common Alerting Protocol in action. Many OASIS standards have gone on to be published at ISO, IEC, ITU, and UNC-FACT. We have 4 illustrious speakers with us today, and we're very honored, starting with Andy Stamford-Clark. Andy is the Chief Technology Officer for IBM in UK and Ireland. We are so honored to have him leading off our webinar because he is the co-developer of MQTT, the MQTT messaging protocol in 1998. And with that, over to you, Andy.
Great, thanks, Dee. It's a real pleasure to be here. Can you flip to the next slide, whoever's controlling the slide? Thank you. So I just want to give a little bit of background on MQTT. You may have heard the anecdotes. I thought you might like to hear the official story. So I'm just going to kind of set the scene. So back in 1998, I was looking to extend the reach of IBM's MQ series product beyond the walls of the enterprise. And we got talking to some folks in the SCADA or SCADA industry who were using pull response over dedicated lines, weird and wonderful protocols, expensive protocols, vendor lock into the max. TCP/IP wasn't really a thing. It was just coming in. Some customers couldn't even spell TCP/IP. It's a really weird time out in the SCADA world. And we figured, what if there's just one more SCADA protocol, one ring to bind them all, a non-proprietary, free to obtain, easy to understand, and thought it was a great idea. And the people we ran it by thought it was a great idea as well. So we, Arlen Nipper from Arcom and I developed in what we would now call an agile way, iterating with some early customers, Williams Energy and Philips Conoco. And we got to the point where the first public version was published in October 99. And that was a real shock for IBM when I said, so I want this document to be in the public domain. I said, no, we have to protect the IP. No, we didn't understand. This has got to be in the public domain. So from the very first word, MQTT was a public domain. Now we would call it open source document and specification. Arlen and I used to joke that we had this modest plan for world domination, that one day all devices would speak TCP/IP and would talk MQTT. And as I mentioned, even that notion of getting TCP/IP onto all the devices was quite a stretch in those days. So that was quite a long way out. One of the coolest things was that MQTT then didn't change for 10 years. It wasn't until we got involved with standardization in OASIS that we made the first change to it. So even with the movement of MQTT across other industries, we quickly moved from SCADA into healthcare and industrial and home automation and medical, also all loads of different industries. Standardizing it was a real challenge, because originally thought we'd standardize it in one of the SCADA protocol organizations, but quickly it became apparent that if you're going to be using this for gathering data from pacemakers, as one of our early customers was, then having it as a SCADA standard didn't really make any sense. So we that's why we settled on OASIS, which then led into ISO standardization. But we've always stayed true to what I've called the founding principles of MQTT. And those have been with us from the very beginning. And even when we've moved into V5, I was the grumpy old man at the back saying, oh, we must adhere to the founding principles. So the first one was that it was a compact on the wire, non-chatty protocol. So it was very frugal with bandwidth. Some of our first clients were using very expensive satellite links, VSAT satellites. And one of them told us that every byte was costing them $1 million per byte per year, they said. So that gave me a huge incentive to trim every bit that I could off the protocol size. The second one was it should be easy to implement on small devices. We originally had a kind of Z80 as a kind of target platform, but certainly something you could write easily in embedded C, no complex serialization protocols or anything hairy. It's something that could be very straightforward to unpack and pack onto the wire. And then the final founding principle was what's come to be known as Andy's 12-page rules. And this is that I hypothesized that, or I observed that any protocol that's more than 12 pages long can't be implemented by two people in the same way. So therefore can't be compatible without significant testing and debugging. Needless to say, the first version of MQTT was less than 12 pages. So that came within my rule, or in fact formed its definition. But the idea was it'd be really easy to understand, very simple structures, really easy to get your head around. And that's really stood the test of time. So Arlen and I had a sort of the Arlen and Andy show. We were on the road a lot, evangelizing both within IBM and creating what is now known as the Internet of Things as a marketplace. The growth was really quite modest or linear, certainly in those days, until when was it 2008, I gave a talk at the OggCamp Unconference. Some of you may have been there, and gave a talk about my home automation project using MQTT and tracking the Isle of Wight ferries and all sorts of cool projects like that. And a guy called Roger Light was in the audience, and he was inspired to rush home and register the name Mosquito with 2 T's. And that day, the first open source MQTT server was conceived and shipped shortly later. And in 2014, Roger put that into the Eclipse, became the Eclipse Mosquito project. And then in 2014, version 3.1.1 of MQTT became an OASIS standard. And in 2016, that became an ISO standard. And I remember it's actually my birthday, so it was in the end of January, which is, we were in a meeting and people kept saying 20922. People were tweeting 20922. I was going, what are you on about? What's this 20922? Anyway, that was the ISO number that had been assigned to us, which I hadn't seen the announcement overnight because it was my birthday. So I was very excited about that. It was really cool. So now, of course, MQTT is the leading protocol for connecting IoT devices. Ian Skerritt tracks these things, and in 2017, we overtook HTTP as the leading IoT protocol on the internet. Some people misheard that as MQTT overtook HTTP on the internet, which clearly isn't true, but as an IoT protocol. And so we then moved on to version 5. And one of the frequently asked questions is, why is it not version 4? What happened to version 4? There's a surprising amount of information on the internet about the answer to that question, but the simple reason is that we went from V3, when we standardized it through OASIS, to 3.1.1. That became version 4 on the wire, because we only had 1 byte for the, that may even be a nibble. No, I think it's a byte for the version number. And so obviously 3.1.1 wouldn't fit into that. So version 4 was that one. And therefore the next one was logically version 5. So perfectly clear in my mind. MQTT version 5 was published late in 2018 and it was ratified as an OASIS standard in 2019. And slowly we'll progress towards another ISO standard for that one, I guess. So that's MQTT in a nutshell. I'm now going to hand over to Florian, who is far better qualified to speak about the intricacies of MQTT version 5 than I am, despite my involvement in the TC that designed it. So chance to listen to somebody else. Thanks, Florian.
Thank you so much, Andy. This is some nice words. I hope I can match them. Let me just really quickly switch over so I can control my own slides. I think this should have worked. So a few words about myself. My name is Florian Raschbichler. I run the technical support team at HiveMQ. HiveMQ is an MQTT broker vendor, and we very proudly had the first MQTT5 implementation out there. Early access, I think late 2018. And I deal with customer real-life challenges in the IoT space on a daily basis. And I'm here to share some of these experiences that I had with all of you and show you which parts of MQTT5 really make a lot of sense and can solve real use cases in the real life. So when it comes to MQTT, here are some of the more popular use cases that that our customers see, or that I see our customers many people these days use in their private life. Certainly connected cars. Dee already mentioned the connected cars, and it's true. When you open your car with a phone, it's likely MQTT these days. Also logistics, and also MQTT is becoming more and more relevant for push notification on mobile apps, actually, and pushing away a little bit the Apple and Google standards there. A very quick intro into the MQTT5 protocol. It certainly is the most feature-rich, of course, implementation of the MQTT protocol. So when this was specified, a lot of the user feedback was gathered and put into the protocol. And our team at HiveMQ was also part of this specification, amongst many other vendors and companies. And key goals are here that we really want to, the protocol really aimed to enhance the scalability for larger systems and to also have better error reporting. This is something that Ian is going to talk about later in more detail. I will be talking about the scalability features in a bit here. Also, some commonly used patterns. So MQTT is a very open standard, as Andy described, and this was the goal. So you could use it for most anything, but there were some patterns that were used across multiple users, and some of those got standardized into the protocol. And lastly, like Andy said, the good performance on small clients that got even improved further. And these days we're at the point where vendors really sell PLCs, where the PLC itself, so the sensor itself, actually is capable of creating an MQTT connection. So I think your tongue-in-cheek idea that Arlen and you had, Andy, is pretty much a reality at these days. So most devices, at least. Some example use cases or some features and explain for a use case. First of all is the topic alias feature. In MQTT, so-called topics are used as the, let's say, communication channel between clients and the publish-subscribe pattern that it uses. And with MQTT5, it is possible that a client and a broker can negotiate a certain number of topic aliases, and therefore a topic, which is naturally a UTF-8 string, can be subsidized with an integer for ongoing communication. Benefits here is that you, of course, you lower the packet size because you have an UTF-8 string that can be, depending on the topic structure, relatively long, and you exchange it with an integer. So you can really achieve lower latencies and really save also on the data consumption. Even if these days it's no longer as expensive, I guess, in the satellite internet days, but still it's relevant, and vendors aim to save data consumption. And here's a concrete example. So this is an MQTT published packet or parts of it. And here we have an example topic. So this would be this is an energy box in Munich sending its consumption data. And when it negotiates with the broker to use topic analysis, then every consequent packet on the same topic will look like this. And now the topic name will be empty, and instead there will be a single integer as the topic alias. And here I want to talk briefly about the V2X, or vehicle to anything use case that are coming up now. We see this with many of the mobile providers. So this means if you're thinking, for example, about a smart city, so we have all vehicles talking, it's pedestrians, whatever have you. And typically here we have really high frequency messaging. So we have 10 or more messages per second, leading to, and also, of course, in a city, there's many thousands, even tens of thousands of devices to talk to each other. And of course, with such a use case, you also get deeper topic structures like the one you can see here, right? So for example, if you're talking about a specific geotile in the Swedish city of Stockholm, and they're sending pedestrian alerts. So this is a 68 byte long UTF-8 string. And now if we replace that string with an integer that has the size of 4 bytes, if we're talking about this happening for 10,000 cars at 10 hertz, over a month, there's a total of 15 terabytes of data that can be saved. And this even in today's world, this is not an irrelevant number. Typically, this topic analysis features or this V2 is used by car OEMs, by internet service providers, and of course, cities themselves also build up infrastructure for this. The second feature I want to be talking about is the shared subscription feature. This is a real game changer, in my opinion, when it comes to specifically larger scale deployments, but even also for not so large scale, which I will talk about show briefly. So what happens here is very straightforward. The name is, so multiple clients can share a subscription. And this can be used for client load balancing. And it's utilized with a special syntax. I have some more slides that will show this in detail. So the special syntax looks like this. So it starts with a $share, then the identifier of the shared subscription is being used. If these subscriptions are used, you can see here as an example, here we have a single client using the topic/status topic. And now these two clients, they share a subscription, share group one, and then topic status. And now here we have a publisher that sends messages to that topic/status topic. And as you can see, first publish comes in, it's delivered to this client and then to one of these two clients. And then for the second message, is also delivered to this client and then to the other one of this client. So these share the load. And the pattern continues. So the balancing of the load between multiple clients is one of the use cases. And then here's a little bit more precise. So why would you use that, right? For example, you have a client that consumes incoming messages and writes them into a database. And here is where maybe you want to really load balance because the frequency of the messages might be higher than the write rate to the database. And so in this example, there's actually 3 clients and not a single client that all write to the database. And the shared subscription feature of MQTT5 makes sure that still all the incoming messages will be unique when they are written to the database. And one more added benefit from this, and also where this can be useful even when the scale is not the problem, is that here also you can achieve high availability or redundancy on your client side. So if you have 2 or more clients consuming the same topic, if one of them for whatever reason fails, you have others to take over the consumption of the messages. Like I said, amongst the benefits is that you can really have a for some reason, your processing of messages is slow. By scaling up the consumers, you can still achieve high throughput messaging, the high availability I just mentioned, and you can really enable really high volume messaging. And a pretty common example here is actually vehicle telemetry data persistence. So like similar to the picture we just saw. So typically, not only can you open your car door with your phone over MQTT, but also over MQTT, the car can send all kinds of telemetry data to back-end services of the OEMs. And we can talk about here tens of millions of concurrently connected devices in a single deployment using all the individual topics to send some information, the VIN as an identifier, for example. And now in the backend, you can build a shared subscription that utilizes the wildcard subscription feature of MQTT. And now you can really scale up this consumer landscape, because the tens of millions of devices will publish many, many messages, and they can all write them to a single data source. And this enables any use case that requires some central calculations, such as predictive maintenance. And with this, I'm pleased to hand it over to Ian Greggs, who is, amongst other things, the Eclipse IoT PMC member.
Thank you, Florian. Let me just share my screen. Hello there. My name's Ian Craggs, and I am a contributor to the Eclipse PAHO project. Subsequently, project lead of that same project. We did implement several versions of MQTT5 early on, so I think there was a bit of a competition between Eclipse PAHO and HiveMQ to be the first, but I think it was touch and go one way or the other. So that was an interesting time to get that developed. I also work with MQTT-SN, which is a version of MQTT which is designed to apply to non-TCP networks. So we're currently undergoing standardization for that as well. So MQTT5 has a lot of really useful features. And I want to talk about improved error reporting at this point. So it's key to mention, I think, that although there are lots of improved and enhanced features added to MQTT5, we still attempted to stick to the principles that Andy outlined at the beginning, including being very lightweight on the wire. We were very aware of being able to, or wanting to conserve as many bits as we could. And I think we achieved that. In some cases, as Florian was talking about, the message flows across the wire for MQTT5 are even fewer or even less than 3.1.1 for the topic aliases, for instance. So you should bear in mind that these new features don't necessarily cost anything at all in bytes on the wire, and in fact can end up with a reduction in that. There is some additional complexity in implementations, but on the client side, certainly, you don't necessarily have to implement all of those features, and there are fully fledged implementations, open source implementations in various places, including Eclipse PowerHover and HiveMQ, to mention two. So improved for error reporting. MQTT 3.1.1 was so lightweight that it sort of skimped on a lot of error reporting, and that was good enough for the time, especially I think on smaller scale deployments. But when you have really large scale deployments, then it can be really useful for client applications to get good diagnostics for the situation that they find themselves in. If you have a small implementation, then it's more easy to do a manual diagnosis and fix of an individual issue. But the bigger the scale of the implementations and the solutions, then the harder that maintenance becomes. So in MQTT 5, we defined a lot of reason codes so that lots of cases, error cases, could be incorporated in the protocol. Again, it's one of those things that helps interoperation between different implementations to have these sorts of things defined within the protocol rather than being defined by a particular user. For 3.1.1, there was really only one or two of the operations that had negative acknowledgements. There was a CONAC and the subscribe operation. And in particular, the publish operation didn't really have negative acknowledgements. So that's been added to MQTT 5. And in 3.1.1, only the client was allowed to send a disconnect to the server. And we changed that in MQTT 5 so that the server can also send that disconnect to the client. And that has an important role to play in allowing more information to, or sending more information to the client application, which I'll expand on. So these are some examples of the reason codes that have been defined in MQTT 5. These are the set of successful return codes. So anything with a value of less than 128 is a successful return code. There's one unsuccessful on this table at the bottom there, 128. One of the examples here, so we've got the granted QS0 and QS1 and QS2 from the SUBAC, which is similar to that was in 3.1.1. A new one is error code or reason code 16, which is no matching subscribers. So that's, for instance, on a publish message, if you send that in for QS1 or 0, with a QS1 or 2, where there is a response from the server and there are no subscribers currently, then you can get that back as information from the server. Then if some action needs to be taken to ensure that the subscribers that you expected to be existing at that point are connected, you can take that before sending that publish again. Similarly, there's a no subscription existed return code or reason code on the unsubscribe operation. So that might be useful information to you that that you were in a different state than the one that you expected. There's also a disconnect with will message reason code. So the client application can send in a disconnect to the server. In 3.1.1, the only way to elicit a will message from the server would be to connect to end the TCP connection directly without sending a disconnect packet. So this can be a cleaner way of allowing or getting that will message to be sent out and updating the state for that client. each of the reason codes also has the ability to add a reason string. So if you need extra information to be sent to a client application or during development for a developer, then you can add an explanatory string along with that reason code. And these are some of the reason codes for an abnormal termination or abnormal result. So we have malformed packet and protocol error. Now, in 3.1.1, the only means that you had of telling the client application that something had gone wrong was to terminate the connection. And obviously that's a pretty blunt instrument. It meant that the client application might retry that operation quite quickly and go through a loop of retries. Or in development, you might have to go back to the administrator of the server to find out whether there was a log message and determine exactly what the cause of the problem was. In MQTT 5, you can get all of that information sent back to you in the client application. So it's much easier to go through the process of development, and implementations are much more flexible because you can determine exactly what the cause of the problem was, and if necessary, the application, or if feasible, the application can go and remedy that situation itself. So one of the examples is publishing without permission. You might be able to publish to some topics and not others. And there's a not authorized return code. So the server can tell you if you weren't authorized to send to that particular topic, that was the case, without terminating the connection, which, as I said, is a pretty blunt instrument. We have negative acknowledgements for all publish operations. So on the left-hand side, we have an example of the quality of service 1, a negative or a 0, hex 80 is unspecified error. So there's on the response to the publish for QS1, we have an error. On the 3 examples on the right-hand side, these are quality of service 2 flows. So quality of service 2 has a 4-way packet exchange. The example in the middle has a return code on the end of the packet exchange on the pubcomp. The 2 examples on the right-hand side have errors, first on the pubrel from the client, the 3rd stage in the exchange, and at the bottom right-hand corner, the 2nd packet in the exchange from the broker. These are more efficient because if there's an error partway through this exchange, then we don't have to send the remaining packets. So we can reduce the bytes on the wire. And in fact, in MQTT 3.1.1, the client application wouldn't know that this publish had failed at all because there was no way of telling it. So this is more informative for the client application and more efficient in the case of quality of service 2 exchanges that terminate before the 4 packets have been exchanged. One of the things that I think is really useful, even more useful, I guess, is server-initiated disconnect packet. So in this case, in 5.0, the server, the broker, can send a disconnect to the client application, giving the reason for that disconnect to happen. One of the reasons might be to tell it to use another server. So if there's a cloud implementation of MQTT, which involves multiple endpoints, we can tell the client application that it should use another server, and there's another property called the server reference string, which can contain an alternative server URI for that client application to use. There's another reason code, 139, for server shutting down. So in that case, the application knows that this isn't necessarily a short-lived situation, and then to wait a bit before trying again. Alternatively, there's some other reason codes which say that, well, the server is temporarily busy. So in that case, we might try again more quickly. So there's lots of ways to interpret, lots of information that can be passed back to the client application, so it can take more appropriate action. The second thing I want to talk about is session and message expiry. So the client application can set a time in seconds for expiry of messages and for its own session with the broker. And the message or the session expires when not used for that time. So in the case of messages, they can expire when, for instance, clients are not responding to a publish from the server. So if we're in the middle of an exchange and some messages are being responded to and not others, then there could be an expiry time set on those messages, and we can, at either end, clear up the information held for that message. So a more efficient operation. One of the uses of this is for what we sometimes called offline keep alive, which is something that existed in MQTT SN before, and is sort of borrowed into or adopted into MQTT 5.0. This is showing an example where we have a connect from a client application saying that there's a session expiry of 10 seconds. That means that once we've terminated that connection, whether through a disconnect or a TCP break, then a session will exist for at least 10 seconds afterwards at the broker end before being removed. This is followed by a disconnect where we can reset the session expiry to a different value if we like. I'm showing an example of 30 seconds here. If we omit that property from the disconnect, then it uses the value that we sent in the connect. So then we leave a time interval less than 30 seconds before reconnecting. And as we have left less than 30 seconds, less than the value of the session expiry, then that session still exists. So when we get the connect back, the session present flag, which is a part of the connect, is set to true, showing that we still have a session. We'll do some more work and then send disconnect again with a session expiry 30 seconds. This time, if we happen to leave a gap longer than 30 seconds and reconnect, then we might find that that session has been deleted. And so we'll get the session present false back. This means that we have to keep reconnecting within a certain period of time to keep that session alive. One of the other really useful aspects, I think, is that we get a simplified clean start operation. So if you want to make sure that when you start communicating with a broker that you have a clean slate, so you want to connect with clean session true, which is called clean start true in MQTT 5, then in MQTT 3.1, if you wanted to carry on from that point onwards with a unit of work that could withstand communication breaks, you have to set clean session equals false to be able to continue QoS 1 and 2 communications over those connection breaks. So to do that and connect cleanly, but allow those connection breaks further on, in MQTT 3.1.1, that was a 4-packet exchange between the client and the broker. You have to start with a clean session true to clean up any existing session, disconnect, and then connect again with clean session false. And of course, that still leaves a window between the first disconnect and the second connect that possibly another client application might come in and interfere with that. With MQTT 5, this is more efficient and reliable. All of this is done in one packet. You have a connect, you set clean start equals true, which only cleans the session at the beginning. Then you can set the session expiry interval to, in this case, the maximum allowed, which is infinity. And this does exactly the same thing as the 4-packet exchange on the left, and is more reliable as well as being more efficient. So I think that's really, really useful. Other examples, this enables housekeeping for for devices which are decommissioned or never appear again. So we have brokers which in the past had a lot of state hanging around for clients which haven't reconnected. This can be automatically cleaned up rather than being an administrative effort in an unreliable sort of way. This can be save the life of your broker if it runs out of storage or memory. We can assign different importance to message types. So different message types can have different values of the expiry, so that some disappear quickly and others stay longer. You might have a message which could be a command which only is valid or meaningful for, say, a minute or so. So it can have an expiry on it, so that it's not going to be executed if it is received by the application after that minute is up. It also, as well as the state of clients' sessions, it enables retained messages to be cleaned up, because the message expiry also applies to retained messages. Some other features of MQTT5 I'll just mention, which we haven't had time to go through today. There's a request response pattern. We have the ability to add user properties. So one very useful potential use case for this is tracking messages all the way across an MQTT infrastructure. We can put in an identifier into the user property, and that can be propagated wherever that message ends up. That's one of the frequent questions that I think that we can get asked in large-scale deployments. You know, where has my message ended up? There's information to denote the type of the payload. There's an enhanced authentication feature to allow challenge response authentication mechanisms, SASL and the like. There's some features which allow MQTT bridge support to be more easily implemented, so that allows MQTT messages to be passed between different MQTT servers, more than one hop, and this allows it to be more efficient and more representative of a real cluster, as it were. There's also the ability to advertise the capabilities of clients and servers, in particular, for instance, the maximum packet size of a client. So where we have a small client implementation and it's not able to handle a packet size of, say, greater than 32 bytes, then that can be advertised, and a broker will not send that message to that client application, which, if it did attempt that, it could cause the receiving small powered or small low powered device to fall over or just run out of battery or whatever. So again, it's one of those features that can lead to a more reliable implementation. So hopefully at some point, we may well have another webinar which talks about some of these other features. And that's what all I wanted to say today. And I think I'm going to hand over to Richard Coppin, who's the chair of the MQTT Technical Committee at OASIS.
Thanks, Ian. Hopefully everyone can hear me. Not entirely sure what I need to do to take control. Is there anything I need to press here? Oh,
just share, I think.
That seemed to do it, didn't it? Oh, too far. Did you go back one? Oh, we've done it. I think we're there. Hi, everyone. Afternoon. Follow that. Okay, so as Ian said, I'm the chair of the MQTT Technical Committee at OASIS. I was fortunate enough to win support to start that journey in 2013, and have been trusted to continue that journey to today. And I wanted to just take a couple of minutes just to make a few comments and observations. I think the first one is that it's finally happened. I've used that photograph and worn the same shirt to the presentation. So that's not quite where I wanted to be, but never mind. So let's move on quickly to the next slide. So I think that the first comment for me is thanks. Thanks to everyone today for taking the time to come and listen to us talk about MQTT version 5. It's a huge amount of work that's gone on in technical committee, and something we're very proud of. So we really do appreciate your time today, and more importantly, your feedback. Also want to say a huge thanks to everyone who was involved in this. And I took a quick count earlier on, and there was in excess of 30 entities involved in that standardization effort. And alongside that, a huge army of individuals who joined the technical committee off their own back. They may have been retired, they may have been working for organizations that didn't have direct OASIS membership, but they made the step to come and engage, which is tremendously powerful and gives us a much wider reach within the engineering community around MQTT. I was just remembering the start of the 5 journey, and we sat in a room and said, what can we do? And everyone had an idea, and I think I started to panic. And at that point, we kind of put up the flare and said, we can't do it all. And what was really nice to see is that group turned immediately collaborative. There was very little ego in that room, but an awful lot of ambition and passion to get version 5 done. And hopefully what we've shown you today, we didn't try and boil the ocean with 5. We tried to add a set of features to make life easier for developers and to enable us to do certain deployments at scale. Very collaborative and welcoming environment, and I want to talk about that a little bit more in just a second. However, this slide here just gives a snapshot of where we are right now, and I'm going to sort of tackle this from bottom left in the clockwise direction. So there's a number of things that's going on in the technical committee at the moment with respect to the core specification to 3.1 and 5. Very much those things are ratified OASIS standards, so that signals to the community that they're stable. However, there is implementation clarification that we continue to offer as a TC. There's a certain amount of currency that needs to go on, and there's a rata and certain process that we need to go through to make sure that remains pin sharp and up to date. More recently, you may have seen that we have started work on MQTT SN, and that's something that Ian and the team have previously spoken about, and it attracted an awful lot of interest when we launched that at OASIS. And that currently has a working draft that's out ready for review. So if you're looking at the OASIS TC pages, please do take a look. You're able to contribute into OASIS even if you aren't a member. We're able to take your feedback and comments and work on those within the technical community. So we would really do that. The other spaces that we are beginning to take a lot of work and a lot of lead time to get a standard out, but now we've got those things done. SN is beginning to get under control. We need to start thinking about how we collaborate with other standards. And I've heard a lot of talk about Sparkplug, for example, and other standards that might fit neatly with MQTT. And the TC is often asked the question, well, what's your opinion on that? And we need to start getting into that space. There's ample opportunity within OASIS for the TC to create collateral, to create assets, and to have an opinion on these things, and to help others who are selling MQTT to CTOs and trying to put it into certain applications to really help that community with the right resources that they need. Andy mentioned ISO earlier. Currently, we have 3.1 has ISO status. MQTT version 5 has been out for a while now. We've had a lot of field feedback, and I think we're beginning to grow in confidence to say, hey, we'd like to advance that to ISO as well. I think there's real ambition in the TC to see these things as coexisting. Again, we'd love to see your feedback on that, but in time, probably relatively soon, we'll start that journey for ISO again. Going around to the final quadrant here, just thinking about futures. I was speaking to Tara Walker from Microsoft and Simon Johnson from uBlocks, and they're getting sort of asking the question, hey, Rich, where's the secret sauce that the editors and the technical community had in their head when they were writing this spec down? Because we can see that this thing needs to be like this, and there's absolute proof in the conformance clause, but where's the context? Where's that kind of oracle that says, hey, this is why you do it, that hand on your shoulder that helps you understand why? So there's a whole bunch of stuff that we need to start getting to start building out those assets. And this is really where I'm saying help, right? There is a real opportunity to come and join the TC to try and help build out some of these assets to make the community a more vibrant and sort of relevant and modern space. So we'd love to work with you on that. Just want to move to the last slide here in the deck. As I say, come and join us. I just wanted to take a moment just to reflect on my own journey. I joined the MQTT community almost a decade ago, and I was reflecting with Andy just yesterday how much that shaped and changed me. You might quite rightly ask, how bad were you before you started the journey, Rich? But I think just in terms of my own professional development, being around this group of people, this 30 entities and all these individuals, these passionate engineers, has really helped me grow. And it certainly changed the way I write things in a technical sense. It certainly changed the way I talk about things and ask questions and empathize with customers and folks who are trying to implement technology. So it's really changed me as a engineer. And for that reason alone, if you're a young engineer listening to this and thinking, yeah, that's great, academics go in a room and come out with a spec and it's law, yawn, I'd like you to challenge that perception. It's not about sitting in a leather chair, smoking cigars and drinking brandy. This is about development and engineering, and this is a great place to really develop yourselves and to challenge yourselves. So on that note, thank you, Andy. Thank you, Florian. Thank you, Ian. Appreciate that. I'm going to hand back to Dee, and thank you very much.
Great job. A little disappointed about the no drinking brandy part, but we'll carry on. That was really good. You guys you're great at this, and I love your enthusiasm. So everybody can see the chat. There's been a lot of back and forth about 311 and 5v5. I don't know if any of you guys want to comment on the conversation going back and forth, or, you know, feel free to do so now if you'd like to do that.
Yeah, so this is Ian. I saw this one question about proxies, and I'm not the best person to answer this, but I think there's no real inhibitor to MQTT using proxies. I think it's down to the implementation of the client application or the client library that's implementing MQTT. I wondered if anybody else has any views on this, but that's my view on it.
Yeah, I was just typing the same thing actually. It's a socket level protocol over TCP/IP. So as long as the proxy doesn't enforce any particular protocol, and it's just a socket level proxy, then there's no reason why it wouldn't go through it. I've certainly proxied v3 through socks and things like that in my time. So I see no reason why v5 wouldn't.
Yes, and in my PAHO implementation on the C clients, it has WebSockets and WebSockets proxies, and so that all works without having support in any particular aspect of that in the protocol. Florian, did you want to add something?
Yeah, I can just match what Andy says. So we definitely have customers using proxies with both versions of the protocol. And maybe to pick up quickly on the 3 versus 5 conversation that also Dee was referring to, while technically the protocols are not interoperable, but by specification, all the implementations that I know of MQTT5 compatible brokers will also accept MQTT version 3 connection. So you can definitely build heterogeneous deployments with both versions. And someone mentioned that a chicken egg problem with vendors not supporting the 5 version and device vendors not supporting 5 until the platforms will. Certainly some truth to it, but yeah, most MQTT broker vendors, at least the ones that I know of, have MQTT5 support at this point. And also there was some conversations about what about the IoT platforms like IBM or Google, and it's being adopted there as well over time.
Very good, thank you. So I'm trying to watch both the chat and the Q&A. I've got some other, again, feel free to go ahead and type those in. Open source what open source implementations are there?
Yeah, on the broker side, Eclipse Mosquito has MQTT5 support, and I know HiveMQ has open source versions as well that support MQTT5. On the client side, PAHO and again HiveMQ. There are some others that implement MQTT5, and I think it's becoming more common, much more common. So one thing I did want to mention or ask other people's views as well is that sometimes I get asked about the next version of MQTT, and my view is that 5 will exist for a long time, and that 3.1.1 will exist next to it as an alternative, and it's horses for courses, and that we're not looking to create a new version anytime soon. It's not like something we want to have with C++, where there's been a million versions, it seems, over the last 20 years. So we're hoping that this is, this is a stable version which is going to exist for many years to come, especially when you're talking about the IoT deployments, which might be, hardware related, and they have to exist for a very long time.
Maybe at this point, quickly, since you're here, Andy, I have I have quoted you saying that is your expectation MQTT5 will be here for decades to stay. Is that a quote that is correctly attributed to you?
I don't remember saying that. Do you mean as opposed to version 6 coming in, or?
Yes, exactly.
I think if I did say that, I was basing it on the track record of version 3, which is that it's been around for a very long time, more than 20 years now. I think. So what I'm observing is that once devices get deployed into the field, people are very reluctant to change protocol version numbers and really low level stuff. They might update security updates and certificates and stuff, but you don't really want to be rewriting the firmware to keep track with galloping version numbers of protocols. If it worked for the implementation, I expect you'll leave it for the lifetime of that product. And notwithstanding the disaster that's coming in 2038 when Unix time wraps around, these devices are going to be around for quite a long time. So yeah, I expect to see V3 and V5 around for quite a long time yet.
Thank you.
Great. So this question about liaising and working with other groups, are there any plan? And Richard, you spoke to this when I think you were talking about the future. Are there any plans to work with Apache's LF Edge and FIDO Alliance more specifically for authentication and onboarding?
Probably best I don't answer on mute. Yeah, I just tried to answer to Manish's comment there. So I don't have a specific plan for those two technologies mentioned. Again, what we often see here is the community has an opinion, whether that is a profile or a way you configure MQTT or use MQTT topic structures or a strategy you have in your solution to make it viable. Then this best practice, this good practice, is often held by a few, and it's great to share, and we often see that on blogs, and we often see that as emails and discussions. Where I would like to see the TC get to is to have an opinion on some of these things, and from the inside the TC, if the engineering brains are there, then it's possible to create assets within OASIS to address those points, right? We need to make sure that we stay within the rules and don't overly favor certain technologies over others, but we can release technical content and implementer support documents. We can put the OASIS stamp and the MQTT logo on it, and we can then provide guidance and help. And I'd love to get there. So I think I'd like to turn that round, is tell me what you think we need and how you might be able to help us get there.
Yeah, that's exactly right. That's what I would say. So come join us, Manish. We need you. And again, we do have a vehicle through which to create liaison relationships. So we'd be more than happy to talk to you about that. Okay, let's see.
One thing I was just going to mention, by the way, is that MQTT Spark plug, which is now part of Eclipse, I think is a really one to watch. So if you're wondering where this stuff's going next, Spark plug defines the payloads, which MQTT very deliberately doesn't. It's payload agnostic. Spark plug starts to define, or does define, the topic namespace and the payload formats for real world messaging. I'm really excited about it, and Arlen Nipper invented it, so it must be good. So have a look at that.
I was in a session just before this one, it came up lots. Our charter is quite clear that we won't go in that space, but also at the same time, we don't even mention Sparkplug. So I think we need to figure that out and agree how we're going to position ourselves there. And there's no reason why we can't play, right? It's just
they're completely complementary. I mean, Sparkplug builds on top of MQTT, so as long as we remain payload agnostic, that's absolutely fine.
Yeah, I think we need to figure that one out for sure.
Yeah, I think putting support for it into brokers will be an interesting next step for people who write brokers. Sorry.
Wow, that was subtle. Okay.
Yeah, it looks like that was directed specifically at you.
Proper name drop, mic drop.
Okay, so, all right, folks, one last round because we're at the top of the hour. We already talked a little bit about added features for the next version, and, where we're going to go for a while. I think we've pretty much covered everything. Again, if we wait, hold on, there's one more here. Regarding liaisons, do we have one with IEC? If not, what's involved with that? Jim, I'd be more than happy to discuss that with you directly. So I will follow up with you. Great question. Thank you for asking it. We would love to work that out.
IEC standard. So short answer is yes.
Yes, right. And I can get you more information on that. So I think we're in good shape there. Let's see. I think unless you guys see anything else, I don't see any other open issues. Any parting shots that you guys want to leave our audience with? And again, we're grateful that you have joined us today.
I'll
I'll
thank
just
everyone for their interest in MQTT and keep using it, keep supporting it, and keep spreading the word. Sorry, Ian.
And that's okay. And I'd like to just plug again MQTSN with the standardization of that's ongoing, which is MQTT for non-TCP networks, so extending the reach of MQTT. So if you're interested in that, then come join us for that standardization effort.
And we will be having a webinar for MQTTSN in the new year, right, Ian?
Yes, that's the plan. Maybe second quarter of next year, where we've made some extra progress.
Okay, we will let everybody know about it. And with that, on behalf of OASIS, I would like to thank Andy, Florian, Ian, and Richard. You did a great job today. Thank you so much. And thank you everybody for attending. We appreciate it. Be well. You'll hear from us. Thank you.
Thanks, everyone. Bye.
Thanks.
Bye.